Yes, I can hear you.
Yeah. So I'm doing my master's in Worcester Polytechnic Institute, Massachusetts. So I'm the first year robotics. So I've not done any projects in the agriculture, but I'm very interested in doing it. Like currently I'm doing my courses on, I'm kind of focusing on navigation, perception, and manipulation. So just trying to get the skills done. Then
Those
I'll
are
be
three
concentrating
pretty
on
big
project.
areas.
Yeah, exactly. It comes with our academic courses, so doing some projects to understand the concepts.
Okay.
So, and currently I'm also looking for um, summer internship this summer, 2019.
Okay. And when does that internship start? Is that like May to August or May to
Yeah,
September?
May to August.
Okay. Fantastic. Well, thanks for joining up. Great to have you here tonight.
Welcome.
Um, Tonight we've got a special guest here, Doran Cox. He is the founder of the Gathering of Open Agriculture Technology, and he's also the founder of farmOS. If you haven't had a chance to take a look at his farm management software open source project, it's pretty interesting. And tonight he offered to join us and talk a little bit about his projects and some of the work he's doing.
Yeah, really looking forward to connecting with this group. Do you?
You can take it away if you want.
Oh, great! Good. Here, I'll turn on my video here in so you can say hi to everybody, and then good to see you all. And I think you had actually reached out, Matt, through the FarmHack website. I think that's how I initially found you, and then that which is, and sort of Goat is sort of an offshoot of that that's more tech focused than just sort of the small scale ag hardware. So Gathering for Open Ag Tech was, we had our first gathering last spring, and here I'll pull up a couple stats here on the gathering. Oops, that's not it. Where are we? Goat overview. There we go. So we were recognizing that that there's a lot of potential for different across agriculture. There's so much innovation, and often we found as technologists that we're doing a lot of sort of making the content accessible to each other, and there was also, but there's a lot of work to connect with each other and dive in deep. And so the idea was that we'd have a goat gathering to do just that. And so we gathered in the near the Berkshires in New York for several days to start that process. And we've had another goat gathering since, and we'll be scheduling some more this year. One will be down in Maryland in April, and then we'll planning one in California this fall. But in general, it's trying to mix different skill sets within the open source software and hardware community and create cross-pollination and intersections and inspiration and information. And so sort of representative of the folks there, we had farm operations software, modeling and modeling, info tools, spatial data, crop planning, data aggregation, and then some front-end tools in agriculture that were represented. But we're really trying to think about what are the general approaches that can, and intersections between all of those that can turn them into sort of more of a coherent suite of technologies that are interoperable. So that was some of the themes, were coordinate our activities across these different communities and coordinate interoperability and sharing, and then build more of some community cohesion and sort of have have a unified philosophy about why, you know, not everybody has to agree, but we have some shared motivations for why we're advocating for this method of research and development. And just, you know, and obviously we're working towards a better information ecology that drives to better outcomes. So that's really it in a nutshell as far as what you know, GOAT is. We've launched a website which I encourage you to join. We've got a discourse forum. We're starting a web series, which I invited Matt to join, where we're going to go into each other's labs and dive in and do some problem solving. Probably not unlike this, your weekly gathering here, but we're trying to profile somebody within the GOAT community and go in a little bit more depth. But so the discourse forums over here, we have a number of different partner organizations that are curating aspects of that. And if you need to, for sort of chat, we're usually on Riot, LinkedIn with some of our own IRC channels. So happy to jump in with folks there. One of the things I wanted to share with this group was some of the particular projects that that we're working on that I thought may be relevant and I hope would be inspirational, because one of the, and I think I mentioned to Matt too, one of the clear, if you go back to that that overview of like who was represented, we didn't have robotics, and we had a little bit of automation and IoT, and we did some work on that, but we really didn't have a great deal of automation and the sort of physical sort of manifestation of a lot of sensing, actually, a lot of spatial orientation and machine learning representation, but again, not in the sort of that intersection of automation and hardware. So it'd be really great to get some, to connect in with your community and see where we can cross-pollinate. I mentioned to Matt that one of the projects that's come out that relates to GOAT somewhat, a little bit beyond GOAT, but is a fairly ambitious project that I've been involved in with the Foundation for Food and Ag Research, and that's actually to assemble what we're calling this open technology ecosystem for agricultural management. And it's really an information-driven system to use our collection of available technologies to inform decisions at the ground level from a farmer's level, but the same technology ecosystem really would apply, I think, equally to automated systems. And so it's basically this collection of observation tools, remote sensing, modeling, and then decisions, which again, I think from your autonomous perspective is probably pretty similar sort of flow, data flow that you'd be looking at. And we're connecting, we're connecting with a network of farms across the country in different production systems to begin deploying and testing that. And that's starting this year. So we have developed relationships with a bunch of different open source observation tools. Again, most of these are app-based, but they are also integrated into those apps, and smartphone apps are IoT devices and so forth for collecting different kinds of environmental feedback data. And that's being fed into remote sensing projects, agroecosystem models for understanding the effects on nutrient cycling, and then back to, again, apps for data interpretation, for making them human readable. But I think that there could be some real opportunity to use the same workflow, like I said, to automation. So a lot of different partnerships that we're working with in different scales and geographies to deploy the tech. And I think I'll skip. Well, I guess we're really moving towards a modular based approach and mixing both human observations with IoT observations and creating an architecture to allow for very disparate agricultural operations to be able to aggregate their data from a research perspective, and also to aggregate in sort of self-organized peer groups, peer-to-peer communication.
Great. Dorn, on that information that you're gathering both from humans and sensors or IoT devices, do you have some of the data standards, or is there some discussion about what formats that data will come in?
Yeah, so that it's a really hot topic because there aren't really a lot of standards for some of the data that we're starting to collect. So we're in the process right now of doing a lot of work on our ontologies and organization, and it's been one of the things that we're trying to address with this project is the really inconsistent data formats that are common in research operations, and just within specialties, the ontologies shift a lot. And so we're not trying to make all the ontologies line up, but try to at least have enough common, have enough of the discussion so we can create interoperability across them, and have at least some core, some core structure to the data to allow to make the translation more efficient. Actually what I'll pull up here is one of their methods for doing that is the farmOS operating system. And so this is basically our attempt to take the basic universal data structure for agriculture and translate it into a management tool that has a fully RESTful API that we can pull and push data from. And by having essentially this universal farm object that could describe any agricultural system, we can use that as basically as the middleware for translating between different systems. And so the basic structure is, again, trying to break down a farm into its universal core components. So every farm, regardless of scale or production system, has areas. And so we define the areas in terms of their an exportable GeoJSON file, or their polygons, points, and lines. And they have meaningful names associated with them, but essentially we create areas and tools associated with generating areas. Then on those areas we have assets. And so assets, for example, and there can be more assets, but basically it's plantings, animals, equipment, and sensors. And then we have groups of assets that can be aggregated as well. And so they all exist in space. And so we can describe everything that's in a farm. And then and then on top of that, we have logs, which is just change over time of any of the assets. And that can also include location and time. So we have time, location, and an asset. And then we have people, which allows for different levels of access to all the aspects of a farm. So between people, logs, assets, and areas, you can describe pretty much everything going back. In order to describe future and sort of predictive analytics, then we also have to have the concept of plans going forward. So it's basically the same data structure, but looking forward. And so the idea here is that, yeah, this is sort of a control panel for any farm, but it's not really the best interface, but it does allow for to access the data in a readable format and browse the database that we're constructing. But really the idea is that, for example, if we go to sensors, is that we can use this to set up lots of different inputs and link in through the API to much lighter weight apps that you'd actually use in the field or connect in IoT devices. So for example, I'll pick one here, a sensor in the field here. And so this, again, has a location. It defines what type of sensor it is, what it's measuring. We can get we've implemented a basic data explorer with Plotly, and then we can actually browse and sort the actual and filter the actual data. But if we go into edit, we can go in and configure that sensor for notifications or basic automation commands, and we can, and then we've got our public key and private key for accessing and allowing data to be pushed in. So that's sort of the general. That's just an example of one of the open source tools that's part of that ecosystem that we're using to help drive interoperability. And again, this can be completely invisible, but it can be used as a way to translate from one system to another. And so we've been working on things like bulk imports of records through, basically translating between different CSV formats to get so we can, yeah. So anyway, that's the quick overview of some of the tools that we've got going. I guess I can go back and just mention the other folks that we're working with here on the satellite imagery analysis. This is an operational tillage information system that Applied GeoSolutions is developing, and their GeoKit software will be made entirely open source this next year. And that will enhance some of our geodata exploring tools, and then their models will likewise are already open source. And then we're working on, again, a whole series of decision support tools. But again, you'll notice here that this doesn't have this same flow, as I mentioned, could also be used for machine learning and basically the same flow for image recognition and sort of ground truthing, sort of learning data sets. And I guess that's a bunch. I'm going to pause for questions. So we're having a lot of fun.
Yeah, that's impressive. That's a lot of information to be aggregating, and that's very helpful. I know we've had multiple discussions on how do we store. We're going to collect just even where did the robot drive, when did it turn on and off, what it turned on and off, where did it plant, how do we store and aggregate that data. So we've just been recently discussing how do we store all of the images for the machine learning pipeline. So these are common questions that we all have. So it's interesting and good to hear your perspective.
Yeah, I mean, I think, like I said, I think some of these problems, if our solutions will evolve, but I think we're going to see a lot of common challenges in dealing with intermittent connectivity and where we're storing the data, how we're syncing up. All those things I think are going to be really similar. So we've been doing a bunch with the IoT, especially with sort of communications in the field and different methods for data. How autonomous is it? Does it need to be web connected the whole time, or can we have this intermittent connectivity as well? So I think those are because again, we're at the edge of doing this with like handheld sensors and mobile devices, but it's really just a tiny step to where that's actually not in a human hand. And I think, again, we're going to be facing a lot of the same challenges. I guess I'll add that one of the things we have done with farmOS is work with, because we can import any geometries, we have actually been doing automated, basically yield data and machine tracks. But again, that's mostly been for record keeping. And certainly for my background, I've been excited, sort of wistfully looking at things like Mission Planner and other systems and say, oh, I'd love to pull that in, instead of, so.
Yeah. Hal, did you have a question on that crop hopper? Or?
Oh, that's a friend of mine up in Nova Scotia that built that off a zero-turn mower.
Did he ever put it into production or any sort of ongoing use?
Yeah, I mean, he still uses it in his operation. I don't think that he ended up manufacturing more than, I might have done 2 versions of it. But I haven't chatted with him in the last year. But I know that I don't know if you've seen the Ogun tractor.
No.
The ex IBM guy started an open source tractor company to redo essentially the cultivating tractor like the LSG, but with all industrial standard connectors and components and bolt patterns and et cetera, et cetera. And so that's a commercially available tractor at this point.
And the name again? I
always have to look it up because it's OGGUN tractor.
Because I have to say you win the prize for mentioning about 20 things that I'd never heard of before. So everything from Riot to farmOS to
well, that's a success. I'm so glad.
Platform you mentioned.
This is what it's all about, right? Here, I'm gonna put I'll put the URL for that tractor in here.
And in one of the farmhack.org websites, I saw reference to Ag Open GPS. Are you personally familiar with what those guys are doing?
No, I just had a little communication similar to you guys. They're on my radar screen and sort of sent a note out and say, hey, we should definitely be in touch. I am in touch with the Open Ag Data Alliance and the Purdue Open Ag Tech, the Oats Center. One of my co-organizers for GOAT is actually starting a professorship there this fall on information ecologies for open agriculture.
One of the things, I mean, the group that Matt has coalesced here has got a number of different focuses, but one of the things that we've been trying to accelerate our learning by focusing in on a single platform and trying to apply some, ROS-based automation to a lawn tractor, just so we can have a number of people focus on something that, you can sort of get your head around.
Yeah.
Because there's so many different disparate areas you could focus on.
So welcome, Mike.
Have you struggled with how to make progress in any one area, and how have you accomplished that?
Yeah, I think that's where the strength of these communities and these smaller working groups. I think the Ogun is a really interesting platform. I think that's their intention, is to have a modular platform that could have multiple power sources and configurations. We've done a similar thing with the work on the Culticycle, but it's not well documented yet. But it's we've been using a lot of the telestrut material to make it fairly modular and easy to adapt to different configurations. But it's when you get into the sort of modular hardware, there's a whole nother set of challenges that I think are really exciting to work on. So you have a group that's also working on that hardware platform? or mobility platform?
Well, I mean, we've tried to separate the challenges, right? We've tried to take an 18 horsepower lawn tractor and pick your word, automate it, make it semi-autonomous, make it supervised, autonomous, whatever words you want to use, but separate the hardware platform and try to take something that, you know, it's already produced by an OEM and just apply the electronics and, you know, path planning and all of the ROS-based technology.
Yeah. So I think that sounds like a great approach.
Hey, Dorn, I'm curious if you have an opinion on what would be a good use case to work on for a robot to work on in farming.
Well, the one I mentioned to you, just because it's it's where the work that I'm doing is soil sampling, which is really just logging the position and then taking a replicate, you know, having a method for replicating that sample, and being able to continue that process indefinitely. To increase the resolution of the map. So some of the folks that I'm working with most closely are developing low-cost hardware for spectral analysis, and the limitation is really generating large data sets for the learning library for that. So it's a you know, it's pretty quick right now for doing it as a manual process, but that everybody who works on that project imagines that that's the next phase is sort of the automated collection process. There are certainly lots of certainly the in between row weeding operations is a really great application for small scale automated systems, and where I think there's a lot of promise in using mechanical weed control and using a smaller platform that again can fit between plants. So I guess that's something that's been brought up quite a lot in recent conversations.
Yep.
You mentioned the farmOS is the Drupal based, the whole, you know, the system, right?
Yes, yeah, that's correct.
Very interesting approach now, and I actually looked into it, farmOS, a few years back. I mean, I'm talking about 3-4 years, 5 years back.
It's come a long way, I think.
Yeah, I mean, and then now that, you know, I'm looking at it, and you have actually given the overview, and just definitely a good progress. And with all of these new things in terms of the modules coming in, you mentioned the machine learning, you mentioned also, you know, the geographical kind of sort of analysis where you are actually bringing in all the GeoJSON files. Are you also doing the shape files and stuff? I believe for the geometry.
Yeah. So we can import. Yes. Yeah. Exactly. Yep.
Okay.
Yep. So we export as GeoJSON, but we can import as KML, and there's a external translation for shapefile to KML to import.
I see. And then you also mentioned the IoT platforms and stuff. So it's just really, really a cool direction, you know, for the farmOS, obviously. And actually, I had a chance to communicate with the Michael,
Mike Senta. Yep.
Yeah. A few years back, and that reminds me that, you know, we just had a couple of emails exchanged for, you know, some of the details and stuff. But the Drupal, and I'm curious now that when we're moving to this machine learning and IoT and all of this geometrical and then geographical, the analysis, are we still integrating that to the Drupal, or do we have you moved to the another platform, or what's the deal there?
Yeah, I mean, I think it comes up a lot as we look at the next phase, and I don't think ultimately it will stay on Drupal. I think we'll probably go through a phase in Drupal 8, but ultimately it will be the core is just that essentially the data structure that we're having, and then there could be, in fact, multiple platforms that just share this structure. And the farmOS Drupal 8 instance will be one version, but I think that the key is just expressions of sort of that common structure that will allow for us to have portability of that core way in which we think about agricultural data. And I think there will probably be a custom language that will be developed. That's what my friend Ankita is working on that. But this is, you know, for sort of bootstrapping. It's kind of like, you know, using the commercial lawnmower to get started. You know, so as a database manager, Drupal is pretty sophisticated with a lot of things that would be a lot of work to build from scratch until we get to that next phase. And then we can start shedding the extra stuff.
Correct. Yeah.
That's sort of how that's how we've been talking about it lately anyway. And so when that happens, I don't know, I think we can scale pretty far. We have a ways to mature, I think, again, the plan is to migrate to Drupal 8 this year. And then we're actually going to be pulling a lot of the Drupal functionality out already. So things like the Geodata Explorer is actually going to be a microservice. Our libraries and everything else, basically everything other than the data structure is going to be shed. And that's happening this year.
Yeah, that makes a lot of sense too.
Because everything's going to, you're going to have all these different interfaces to it. And basically we're just going to have a database in the back end.
The another point that I wanted to raise, and Matt already, you know, touched a little bit, you already said those is a little bit of complex territory, which is the standard data format for the exchange.
Yeah.
Is that because I see the Godin mentioned, you know, at your, you know, website, and I think I worked with the Godin in the past already. The common language, in terms of the agriculture where we wanted to share data, it's not possible still.
Yeah, and I don't think we're going to get where it's going to be common all the way around, but we just need a way to create, you know, have at least be clear and make conscious decisions about why we're making those choices, and then create interoperability. I think that at least that's been the latest conversations I've had with folks.
Yeah, and I heard the Godin also drives a lot of open data, and then advocate, you know, that just opening up data, and then they work with different countries, ministries, you know, different regions, you know, but there's nothing about sort of, you know, the format, you know, which could actually link all of these things together.
Yeah.
For the farmOS, if you guys have to pick, let's say I have heard about the OADA too, and then they just also do the standards for the you know, data, at least over here in the US, probably. So US, Canada, and then maybe some other countries might be able to use that. If you guys have to pick up a one open data format, which one would you go for? I mean, at this point, what's the take on?
Yeah, no, it's funny. It's the conversation we're having right now because we're in the middle of deploying. We're having to make some of those decisions this year. In the next 2 months, particularly around some of the plant and input libraries. And tillage libraries and so forth. So we're going to use some of the USDA stuff because we have a lot of partners in USDA for, say, tillage information. Our plant ontologies, we have a friend of mine that's what she's been working on for the last several years on sort of sifting. So I can't express what her strategy is on that, but she has a particular strategy about how we're going to navigate these different plant species ontologies and which one will be the default, and then how the rest of them will sort of build on top of that. Because as we get into because there's so many ways to describe a plant.
Right. Yeah.
I mean, beyond species. I mean, the species is like the easy part, and naming conventions, like that's easy. But as we started to get into sort of the way they express, the phenotypes and their interactions and so forth, it gets really, and not to mention genetic, as we start to do, we're layering on these crazy data sets with the genome being and functional groups associated with the genome. I mean, that gets really big really fast.
Wow. Yeah, absolutely. Have you heard about this OADA though? Like they're also OpenAID data standard.
Yeah,
OADA.
so that's part of Purdue. That came out of Aaron Alt's. I mean, Aaron Alt and Dennis Buckmaster are both part of the sort of the Go community.
Okay.
And so we have not formally linked. It's funny because we have a lot of conversations, but this is kind of where we're at. Like, yeah, we need to make these things work together, and it makes sense, but we haven't done it.
And I'm just excited and curious to know that what the open source communities like you guys what they're picking up and what they're thinking about the the open data formats so that at least if you get some direction we would know that okay which one
I feel like that's the most important thing is to pick something and then and then just assume that we're going to have a new version and figure out why that doesn't work. But at least we pick something, express it, and go with it with enough critical mass around it that we start to move. And that's kind of been the approach even with farmOS is like just have enough. Just it's not the right schema yet, but it's better than what we had before, and we're getting feedback. So.
That's true. Yeah, I've gone through the schemas like when I was looking into the data formats and stuff like a few years back. Obviously, this might have changed now, and you guys have actually added many things, which I was looking at it, and so that's great.
Yeah, I mean, and things like we had to add basically for every log. Also, not only has a time stamp, but also has the ability to add a geolocation to everything, and that became really important. Fairly early on. It wasn't part of the early one, but it became one of those things. It just has to be part of the structure.
Absolutely. Well, that's all from my end. Thank you very much for coming by and give us a little intro onto this farmOS and stuff.
Oh, it's absolutely my my pleasure. It's really fun to share. Again, hope we can recruit some of you to join some of the in-person gatherings as well. And like I mentioned, we're trying to get this web series up where we'll have present a little bit more in depth. So it would be a great opportunity. I would invite all of you to share your work. And it's not fully formed series yet, but would love to. I think it's because it is challenging for us to all get together, but I think there's a lot of value in diving into some of these issues.
Totally agree.
And I saw your recording, so that's great.
Okay.
Yeah. Are there any more questions? I don't know if Kalyan, if you had a report on the machine learning and if Sam wanted to cover on the path planning. There's a couple of the ongoing projects we've been working on.
So Matt, I'm still working on it. I get just a little time over the weekend, so I didn't kind of progress much, but I think it's just work in progress. So at this point, I don't have anything to share, like from last Thursday probably, but I'm hoping to work on it maybe into the coming week and the weekends.
Okay. I didn't know I don't know if there's any portions to break out, like if we wanted to attempt the area coverage, or if Chinmay was interested in working on like an area coverage, or what part of navigation he's interested in, or if there's some cycles available.
Sure, we can. I can cover that because I'm already trying to get the help on that. On the not on the tracking side, but on the path planning side, and for everyone's benefit, I can actually go through it, and that's actually also we have it in the PDF. That what we have. So let me hang on. Let me see if I can actually open that up. So basically, for the path planning, let me see if I can find the PDF first. Oh, we are already on the Slack channel, so let me go there. Okay, so I'll be in the lone tractor. And put it further up. Okay, here you go. I'll share my screen. Okay, let me know if you guys can see my screen.
Yep, we can see it.
Okay. Yeah, so basically for the current, the work in progress sort of deal, what we're planning to do is these are the two, the objects currently in progress. The one is for the path planning for the tractor and then path tracking for the tractor. And then these two are like sort of our next addition to the package for the lone tractor that we're trying to build. And that's just basically we're doing it in iOS. So path tracking, it's just currently being worked on, and then there are like a lot of detail that we talked about, and then also, I mean, I'm having almost 60 to 70% of the work kind of completed on that. I have still 30-40% work to go, and then I'm actually should be able to simulate that. The help that I'm looking at is on the path planning side, and then this is not going to be like a simple path planning thing. Like what we're trying to do is basically you're provided, for example, I have given it over here, like sort of use cases that how we wanted to actually see that. So for example, the use cases would be tractor should move from point A to point B in a straight line path. And if you have the farm GPS locations, tractor should be able to actually build the straight line path and so be able to track the path. So be like sort of, the U joining lines, and then tractor would start from one end of the farm and then it just stop on the other end of the farm. And also you have an opportunity to have like a waypoint, the map for the farm. So for example, this is the use case where, you were getting the kind of a planting map where you wanted to track, your tractor just for the planting, and you wanted to actually track that onto the prescribed path, which means you have those waypoint map, and then you wanted to follow that. So those are sort of use cases. Like I said, the path tracking is already kind of work in progress. Path planning is what we're actually trying to get some help on. And basically for the path planning, this is what we're thinking. Let's say, for example, this is purely the path generation, so you are given the farm coordinates, like it could be in any sort of polygon, you can have at least 3 points. Those are the GPS locations which could define your farm. And then we wanted to actually build, the polygon based on that, and then we wanted to do some math and create a path, within that polygon. It could be north, the south, east, west sort of lines, whatever is just convenient based on certain parameters that we can input. And then our output be a waypoint path. So be like starting from point A to, all the way to the starting point to the end point. And be like, it should have your X and Y coordinates. If you are into the GPS locations, you may have that converted also into the GPS points. And then sort of, we also need at that point that you should have the path yaw. So it means that the orientation of the path point at that point, so that it will help us actually tracking, a vehicle, onto the path. And then there are like some math behind it that it would help us if we have the X, Y, and the yaw for, that path. computing wise, I have actually written like very high level points that, how we're going to process the polygon, and then we're just going to generate the continuous parallel offset path. We just wanted to inject the points, smooth out the path if needed. We just wanted to, like the another array would be calculation wise, we just wanted to keep tab of the distances between the points. We also wanted to, if you have the U-turns, or the, sort of golf loops, like, the turnings, you also have, you can also, calculate the curvature of the path at each and every point. For straight line, obviously, it would be 0. For the turnings, you would have some value of the curvature, which would be helpful, in calculating the velocities. If you're not running with the constant velocity, and if you wanted to tune your parameter, and then you wanted to adjust the velocity based on the path you're tracking, sort of a deal. And then finally, you just wanted to store, those indexed lists. You can enumerate, if you want. You can have X, Y, and Y. You may have a distance also included already into the list, or maybe a separate list. You can output the curvature parameters, etc. that you can do. So this is the second path planning node, which is like the path generation that we need help with. So if you guys have, I'm right now doing the path tracking node into ROS Python, but language, I don't think it matters. If you have an idea and if you are willing to work on, like, through the ROS, and we're using the Kinetic at this point, and our packages are also in Kinetic. C++ and Python, both languages are welcome. And if you guys, have any insights, or if you guys, just wanted to start working on the path planning node, you're more than welcome to do so. Any questions?
That's good. Chinmay, have you been working on area coverage at all?
Hello. Yeah, I got the concept of Kalyan, so I'm interested in working with the path tracking and path following. So let me know more details about it.
Sure.
Okay.
Hey, Sam.
Yes, sir.
I'm curious to know about the calculate curvature of the path part. I was wondering how that works with the tracking node. Can you please elaborate more?
Sure. So basically, let's say, for example, that is for the variable velocity. So, for example, the curvature is like nothing but the the inverse of the radius. If you're going onto the constant velocity and then you're tracking the path, the curvature at that point does not matter much. But if you wanted to have the variable velocity that you wanted to set, like your maximum and the minimum velocity in between, sort of velocity you want it to slow down, where you are actually hitting the sharp curvature, which is like exactly the kind of a sharp turn. So you want it to slow down. If you have that parameter, you should be able to slow it down based on that information about that actually point and the curvature at that point. That what you're dealing with, sort of, and so, for example, mostly for the straight line, you can have a more velocity if you're going and tracking this, the straight line, shouldn't be a problem. But I think it just comes into the picture where you are into the headland, you want it to turn slowly. You might want to use the curvature parameter to slow down.
Okay, yeah. Sure, thanks. And the other question is, how does the path tracking part of the program work with turns? Just the turns that you mentioned, or are you planning to have the path planning node do the work, and the idea is to just follow? Because from what I understand, the path tracking node takes or would try to follow A-B points. So would that mean that the path planning node is supposed to give a number of smaller A-B lines to represent a curve or a turn.
Correct. So your path planning node, it's essentially your planner, which is sort of think of that as a global planner. So you're planning your trip from one city to the other, and then you put those two cities into your Google Map, for example, and it will map it out the path for you depending on your parameters. My path planner is exactly sort of like what I'm thinking it's the global planner. So once you have the field coordinate and once you have the polygon defined, it will do the math and it will just draw those points at certain distance. For example, if I say I needed a point every 0.2 meters or every 0.5 meters or every 1 meter, it would start generating those points and it would give me like the whole path starting from beginning to the end, which would cover the whole field based on the parameter you provide. Yeah, so I'm expecting X, Y, and even yaw at that point for the path. So for example, you're considering you were actually, I wanted to have a straight line and I wanted to follow, let's say, just south to north and north to south. So I go my first starting point where it's starting from south to north. So I will have my parameters phi, and then my heading should be like 90 degrees because I'm actually heading north. So I want that point to be stamped as my X, Y, and yaw. So that's the path planning node's job to give me that, the detail.
I had a doubt about it. So you're planning to make a path based on the GPS inputs, but is it only inputs you're going to take, or you're going to take on other inputs, like because GPS is not much accurate? So you're talking about the paths with 1 meter, 2 meter.
So the basically GPS in this case is going to give me just the static coordinates, like which defines the field as a polygon. So we're not relying that's not like something dynamic at this point. This is like you're defining a field based on your GPS location. So that would help us build the path within that field.
Right. So in other words, that means that the path planning node is an offline algorithm, while the path tracking node is an online algorithm trying to follow the path. Is what
Absolutely. Because for the path tracking, you would need a tractor. You would also need the tractor localized. You'll also need the tractors equipped with the GPSs, and it has this, the odometry, that, it would actually spit it out. And so that we would know, its X location, its Y location, its heading, everything. And that's the localization of the tractor, which would help us, go and find out the closest point based on where the tractor currently is versus where the nearest closest point is. Make sense?
Yes. So what are the other sensors you are using for localizing?
So for localization, we would have the GPS. Obviously, we would have. We can also incorporate and the what do you call the encoders. We got the IMUs. So those are the basic sensors right now. Right, Matt? Like this is like all we have, right?
Yeah, wheel encoders, IMU, and GPS is the current thought. There's been some talk about using a vision system for visual odometry, but we're not totally there yet. So
Okay.
the first run would be wheel encoders with IMU and GPS.
Okay, got it.
And the robot localization, that's the package that we wanted to use to localize this. But if any other packages that would localize, we're welcome to actually use that and then at least take a look at it if it's something more reliable. The robot localization, the whole package is a really nice package actually, but it's also extensive.
Great. Thanks, Sam.
Well,
Kalyan, I don't know if you want to talk a little bit about what work on the perception this week.
Sure, I'll be happy to talk about not only some of the victories, but some of the little battles and the losses, defeats we have along the way right now. So Matt and I, for those some of the folks who were there in the perception channel, one of the idea which was pitched, I think Sam, Matt, everybody pitched was, can we build a weed detection system and kill the weed while the robot is moving or the lawnmower was moving, right? So as part of that project, we wanted to build up a camera-based system which would detect the weeds. So the camera would be placed at the bottom of the tractor, and we would find the weeds in the field of the view, and we would probably come up with a mechanism to spray to the weeds and kill them. So what we were thinking was get the image from the camera and then pass that to the Movidia stick to do detection using neural network there, and then we would pass the output of those computation to this the sprayer system. So Matt has got the Movidia stick up and running on Raspberry Pi now, but then we are trying to integrate that into ROS and other systems, and we are having all kinds of fun installation, co-location of software and all those. But at least he got the camera up and running with the default example, so that's a great progress on that end. So yeah, I think Matt just posted the Movidia stick for some of you guys who haven't seen it. It's pretty cool. It's a very tiny chip. It's low cost and good for our application. Meanwhile, I've been working on getting a YOLO V3 detector working so that we can custom train the default object detector to capture the weeds and non-weeds. So what I was working on was building a model for it. And yeah, Matt, you want to show the image?
Go ahead, talk about building your model.
No, go ahead. Sure. This
is YOLO running. YOLO running on the Raspberry Pi with a Movidia stick. So just showing that you can bring in an image from the camera, and then it can
detect
localize each of the objects and then identify them.
And now we want to, because that's working now, we want to take that and create a custom model so that it can detect other weeds. And then Matt also found a cool package which can take our custom detector if we get it working, and sucking that into a ROS node, and the ROS node will broadcast the objects within an image, which we can use for other parts of the ROS system. So we have all these pieces. Now we're just trying to get all the pieces working seamlessly and get them going as quickly as possible. So there has been some challenges in some of those. So I want to share, what I wanted to share was, let me see if I can share. Can you guys see my screen?
Yes.
So
Yes.
what I've been working on was the object detector, custom object detector. I had my own issues getting the YOLO detector working from scratch. So then I went back to a simpler objective, which was, can we take an image and find the largest can we take an image and then we train for some of the classes and display only the class which has the maximum area. So that's what I've been working on. I think I was able to get the model to a good state now. Now, at some point, once we get this working, then we want to use multi-object detection. So rather than just one object in this, I wanted to see if I can get it, multiple values detected in it. There are already a lot of code on YOLO V3 and other object detectors online. I was being stubborn to build everything from scratch. So just so that it becomes easier for us to debug those models if we are stuck at some point of time. I'm going to see if I can get this from ground up by the end of this week. If not, I might go and copy and paste the code from other people and just get this going a little bit faster. But overall, the model, one of the things I noticed is that the model was able to predict very well. I don't know if it's clear. You can see the red dots here. So this was the ground truth. And then my predictions were somewhere here. And then now I'm having some visualization issues. So all these detections were happening outside the image. I need to get my visualization a little bit right. But overall, like I can eyeball them, I can look at the values, and it seems to do a good job so far. So if I can get the visualization working, that would probably in a day or so, that will be a good step. Then we want to move that to multi-object detection. And if we get that working, what I want to set up is I want to set up a folder where people can add in whatever types of object categories they want to be detected with the custom detector, and point to that folder so that automatically we can train new objects and modify the detection mechanism for different things. So right now the idea is to detect weeds and non-weeds. In future, we might want to add fence to the object detector. See if we want to stop the vehicle when we detect the new fence. So the idea is to get something simple up and running, and then we can keep on building on more complicated systems at some point. So that's all I got. Don't have a
Excellent. That's
great.
a lot of work. Thanks, Kalyan. Are there any other comments for tonight's meeting? Okay. Well, thanks again, Dorn. Excellent to have you here tonight. Thanks for your presentation.
Thank you.
Great seeing everyone.
Right.
Have a great week.
Yeah. Thanks, Matt. Thanks, guys.
Good night.
Thanks. Good night.
Thank you. Bye.